In this video, we will solve some College Board multiple choice questions pertaining to rates of change of polar functions. This is AP Precalculus, topic 3.15. If you appreciate the content, please give it a like. Number 1 is calculator active, so we will use our graphing calculator as needed. The table gives values of a polar function r equals f of theta for selected values of theta. If the value of r equals f at pi over 12 is estimated using the average rate of change of the function on the interval from 0 to pi over 6, which of the following is true? Using average rate of change to estimate the value of a function means using a linear equation in point-slope form to estimate the value. We always use point-slope form because all we need is a point and the slope to write the linear equation. The point can be any known input-output pair, and the slope will be the average rate of change on the given interval. Since we can use any known input-output pair for the point, why not keep it simple and use the point 0, 0? For the slope, we need to calculate the average rate of change on the interval from 0 to pi over 6. Way back in topic 1.2, we learned that the average rate of change of f on the interval from a to b is given by f at b minus f at a divided by b minus a. So on the interval from 0 to pi over 6, the average rate of change of f will be f at pi over 6 minus f at 0 over pi over 6 minus 0. F at pi over 6 is 5 radical 3 over 2. So we have 5 radical 3 over 2 minus, and then f at 0 is 0. And then that's divided by pi over 6 minus 0. We can go ahead and erase these minus zeros, which are not really doing anything. When you divide by a fraction, you multiply by the reciprocal. So the average rate of change becomes 5 radical 3 over 2 times 6 over pi. This is 30 radical 3 over 2 pi, which reduces to 15 radical 3 over pi. This is the average rate of change of f on the interval from 0 to pi over 6, and it is also the slope of the line we will use to estimate the value of f of theta. The point-slope model of a line is usually written like this. However, since the input values are values of theta and the output values are r values, I'm going to replace the y's with r's, and I will replace the x's with thetas. It is traditional to write polar coordinates in the order r, theta, though in this case it doesn't matter because both are 0. So let's write the linear equation. It will be r minus r1, so r minus 0, is equal to the slope, which is the average rate of change, 15 radical 3 over pi, times theta minus theta. So this is going to be theta minus theta, which is 0. So let's erase these zeros which are not doing anything. So we have r is equal to 15 radical 3 over pi times theta. So this is the linear equation that we will use to estimate the value of r at pi over 12. We just need to evaluate r at pi over 12. Substituting pi over 12 for theta, we have 15 radical 3 over pi times pi over 12. The pi's cancel each other out, and we have r at pi over 12 is equal to 15 radical 3 over 12. Let's use the calculator to come up with a decimal approximation. Make a vertical fraction by hitting alpha x, and we need 15 radical 3 over 12. 2.1650. I recommend always using 4 decimal places and never trying to round. To avoid losing decimal place accuracy, let's store all of these decimals into a letter on the calculator. I'm going to use letter C. Hit store and then alpha C and enter. In all of these answer choices, we are comparing our estimate to the actual value of f at pi over 12, which is 5 over 2 or 2.5. Putting the actual value side by side with our estimate, we see that we are underestimating, but by how much? We can find that difference by doing 2.5 minus the value of C. We are looking for the answer choice that says our estimate will be an underestimate by 0.3349. Rounding to 3 decimal places, the answer is D. The estimated value would be an underestimate of the actual value by approximately 0.335. Number 2. Consider the graph of the polar function r equals f of theta, where f of theta is equal to theta times theta minus 2 times theta minus 4 in the polar coordinate system on the interval from 0 to 4. Which of the following statements is true? All of the answer choices are about whether the point f of theta comma theta is getting closer to the origin or further away. My strategy will be to make a quick rectangular sketch of f of theta. It's already given in factored form, so we can tell that the zeros, the x-intercepts, are at 0, 2, and 4. So we have x-intercepts here, here, and here. I'm going to make a quick sign chart to convince myself of where f of theta is positive versus negative. Theta itself is equal to 0 right here at 0. It's going to be negative to the left of 0 and positive to the right of 0. The factor of theta minus 2 is equal to 0 when theta is equal to 2. This factor will be negative to the left of 2 and positive for values of theta that are bigger than 2. Theta minus 4 is equal to 0 when theta is equal to 4. This factor will be negative for values of theta less than 4 and positive for values of theta bigger than 4. To determine whether f of theta itself is positive or negative in each interval, you can just count the number of negatives. For an odd number of negatives, f of theta will be negative. I see 3 negatives. F of theta is negative for values less than 0. Between 0 and 2, we have 2 negatives. A negative times a negative is positive. We have an odd number of negatives between 2 and 4, just the 1. So f of theta will be negative in this interval. And f of theta will be positive for values of theta bigger than 4 because each factor is positive. So that tells me that f of theta is negative to the left of 0 and then positive between 0 and 2 and then negative between 2 and 4 and positive for values of theta bigger than 4. So this would be a rough sketch for f of theta. On a rectangular graph like this one, the x-axis represents the pole. All of the answer choices are about the tiny interval from 2 to 2.1. So we are talking about starting at 2 and moving a tiny bit to the right. So at 2, we are at the pole. We are on the x-axis. We are starting at the pole. And then we are moving away from the pole as we move to the right. So the distance between the point and the pole is increasing on the interval from 2 to 2.1. Only options A and C say that the distance between the point and the origin is increasing. So we can eliminate options B and D. We can choose between A and C by looking at the justification. Option A says because the values of f of theta are negative and decreasing. And yes, as we move to the right of 2, the values are negative, see how they're below the x-axis, and decreasing. This portion of the graph between, we don't know exactly where the minimum value is, but certainly a tiny bit to the right of 2, we see that the graph is falling. It is decreasing. So, negative and decreasing. So the answer is going to be A. Glance at option C, which is going to turn out to be wrong, but let's look at this bogus justification. Because the values of f of theta are negative and increasing. Well, they are negative between 2 and 2.1, but the values are decreasing, not increasing. So the answer is A. By the way, we could have eliminated some of these options without graphing f of theta, sort of just by the vibes. We have learned that when these adjectives describing f of theta sort of sound the same, that's when the distance from the origin is increasing. So look at these words, negative and decreasing. Do you hear how both of these words sort of sound the same? They have the same vibe. When f is negative and decreasing, the distance from the origin will be increasing, not decreasing. So we knew that B would not be the answer without looking at any graph. On option C, we were told that f of theta is negative and increasing. Do you hear how these sort of sound different? They have a different vibe. That tells us that the distance from the origin is decreasing, not increasing. So we could eliminate option C without looking at any graph. We could not have eliminated option D. Values of f of theta are negative, but increasing. These words with opposite vibes tell us that the distance from the origin is in fact decreasing, which is what it says. Similarly, option A does make sense because f of theta is negative and decreasing. So the distance from the origin should be increasing, which is what it says. To choose between option A and D, you would need to sketch or at least imagine a graph. This does not affect the answer, but I just realized that f of theta is only defined between 0 and 4. So when I made my sign chart, it really just should have had these two middle columns. Number 3, consider the graph of the polar function r equals f of theta, where f of theta is equal to 2 sine theta minus 1 in the polar coordinate system. Which of the following descriptions is true? These options are all about whether the point f of theta comma theta is getting closer to the origin or further away from the origin on the interval from 0 to pi over 6. My strategy will be to sketch a rectangular graph and use that to answer the question. The minus 1 on the end tells us that there has been a vertical shift down 1. A translation, if you will. There's a new midline at negative 1. The 2 in the front is the amplitude, so the maximum value will be up 2 from the midline, and the minimum value will be down 2 from the midline. This is a sine function, which tells us two things. We know the period to be 2 pi, and we know what the shape of the graph looks like. But let's get these input values down. So 2 pi will be the end of the period, halfway will be pi, and this will be pi over 2, and right here will be 3 pi over 2. One period of f of theta will look like this. All of the answer choices are about the interval from 0 to pi over 6. So if you were in a hurry, you could probably assume that the interval from 0 to pi over 6 is going to involve this little piece of the graph, like from here to here. If you wanted to be mathematically certain, you would calculate the value of this x-intercept by setting f of theta equal to 0 and solving. I'm going to do that really fast. 2 sine theta minus 1 is equal to 0. Adding 1 to both sides, that's 2 sine theta is equal to 1. dividing both sides by 2, we get sine theta is equal to 1/2. The sine of what angle is equal to 1/2? Well, especially in the first quadrant, we know the sine of pi over 6 is 1/2. So this very first x-intercept is pi over 6. So the interval from 0 to pi over 6 is in fact the little blue highlighted region. Option A says, on this interval, the value of the function is increasing, and the distance between a point on the curve and the origin is also increasing. Is that true? First of all, the r value is in fact increasing. We can see that the r value is rising as we go from 0 to pi over 6. So far, so good. But what about the distance between the point and the origin? Well, the origin is represented by the x-axis. As we move from 0 to pi over 6, we are getting closer to the origin. So the distance is decreasing, not increasing. So option A is not the answer. Option B says the r value is increasing, while the distance from the origin is decreasing. Well, that's exactly what we saw. So I'm going to go ahead and circle that the answer is B. Now let's look back at it one more time. The r value is increasing, while the distance from the origin is decreasing. From left to right, the r value is rising, but we are getting closer and closer to the origin, closer to 0. So the answer is B. We can very quickly eliminate options C and D, because they both say that r is decreasing from 0 to pi over 6. And we can clearly see that r is increasing. Again, the answer is B. Number 4. Consider the graph of the polar function r equals f of theta, where f of theta is equal to 4 sine 2 theta in the polar coordinate system. On the interval from 0 to 2 pi, which of the following is true about the graph of r equals f of theta? Let's sketch a rectangular graph for f of theta. There is no vertical shift, so the midline will be at 0. This will represent the origin, also known as the pole. The a value of 4 tells us the amplitude, up 4 and down 4, from the midline. This b value indirectly tells us the period. For the sine function, the period is always given by 2 pi divided by the b value, so 2 pi divided by 2. In this case, that means that the period is equal to pi. That's why I'm going to count out 4 quarters of a period, 1, 2, 3, 4, and I'm going to call it pi. This will be the end of one period. Half of pi is pi over 2, and half of that is pi over 4. This is 1/4 of a period, and I can use it to find all of the remaining missing values. I'm going to simply count by pi over 4. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4 reduces to 3 pi over 2, 7 pi over 4, and 8 pi over 4 is the same as 2 pi. We have memorized that one period of the sine function looks like this. And there's a second period for you. Option A says, for the input values theta equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4, the function r equals f of theta has extrema that correspond to the points that are farthest from the origin. Remember, the x-axis represents the origin on a rectangular graph such as this. So the extrema that are furthest from the origin will be points like this one, and this one, and this one, and this one. Each of these points is at the maximum distance of 4 away from the origin. And that's at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. These are exactly the input values at which option A says we will find the farthest points from the origin. So the answer is A. Let's quickly determine why the other three options are incorrect. Option B says that for the same input values from option A, we will have extrema. However, only the points corresponding to theta equals pi over 4 and 5 pi over 4 are farthest from the origin. And that's not true. At pi over 4 and 5 pi over 4, these points are 4 away from the origin. But also at 3 pi over 4 and 7 pi over 4. It doesn't matter that these are negative r values. The distance from the origin is still 4. That's why option B is incorrect. Options C and D are both incorrect because they both say that at theta equals pi over 2 and 3 pi over 2, f of theta has extrema, meaning a maximum or a minimum value. However, at pi over 2 and 3 pi over 2, the r value is 0, neither a maximum value of 4 nor a minimum value of negative 4. These are not extrema. And certainly none of these points are farthest from the origin. These points are at the origin. Number 5 is calculator active, so we will use our graphing calculator as needed. The table gives all of the relative extrema of the polar function r equals f of theta for all input values of theta in the domain of the polar function. Which of the following statements is true about the graph of r equals f of theta in the polar coordinate system? Before I even read the options, the setup is telling us that we are looking at all of the extrema. That means 3 is the maximum value of r, and negative 4 is the minimum value of r. But what is the greatest distance from the origin? Here's a quick rectangular sketch to help you visualize what's going on. Remember that x equals 0 represents the origin. At 0, we have a relative max of 2. At pi, we have a relative min of negative 4. And at 2 pi, we have a relative max of 3. These are the only extrema. Notice that at 2 pi, we have the maximum value of r, which is 3. However, at pi, we actually have the maximum distance from the pole, which is 4. It doesn't matter that this is a minimum value of r, which is negative 4. The distance from the origin is 4. We can eliminate options A and B right away. They both say that the maximum distance between a point and the origin is 3. We just saw that the maximum distance between a point and the origin is 4. Option C says the greatest distance between a point and the origin is 4 because this is the maximum value of all extrema. No, the maximum value of all extrema was 3. This point that is the maximum distance from the origin has a value of negative 4. It is not the maximum value, it's just the maximum distance. So the answer is not C. So it must be D. Let's see what D says. The greatest distance between a point and the origin is 4 because this is the maximum of the absolute values of all extrema. That's true. The absolute value means the distance from 0, and it is always positive. So taking the absolute value of the extrema tells you the distance from 0. And now we see that the distances from 0 of these relative extrema are 2, 4, and 3. Again, the greatest distance between the point and the origin is 4 because this is the maximum of the absolute values of all the extrema. Not sure why that one was calculator active. Number 6. Consider the graph of the polar function r equals f of theta, where f of theta is equal to this expression in the polar coordinate system. Which of the following is true? All 4 options are about the limit as theta approaches infinity. As theta approaches infinity, only the highest degree term in the numerator and the denominator is going to actually matter. We can ignore the plus 50 and the plus 5 without changing the limit. So the limit as theta approaches infinity of f of x will be the same as the limit as theta approaches infinity of 3 theta to the third power over 2 theta to the fourth power. This expression simplifies to 3 over 2 theta because 3 of the thetas in the numerator cancel out 3 of the thetas in the denominator, leaving 1 extra theta behind. As theta approaches infinity, the denominator gets bigger and bigger and bigger, while the numerator stays the same. Therefore, the overall value of this fraction gets smaller and smaller and smaller, closer and closer and closer to 0. So that is the limit as theta approaches infinity of f of theta. We know the answer is B right away because that's the only one that says the limit is equal to 0. But let's read it. Because the limit as theta approaches infinity of f of theta is equal to 0, the points on the graph of r equals f of theta will be arbitrarily close to the origin for sufficiently large values of theta. Remember, f of theta is equal to the r value, the distance from the origin. So, in a fancy way, option B is just saying the same thing as this limit statement. As theta gets bigger and bigger, the r value gets closer and closer to the origin. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.